There are many unsolved problems in physics, ranging from the very small to the very large, from the very old to the very new. Some of these problems are theoretical, meaning that existing theories seem incapable of explaining a certain observed phenomenon or experimental result. The others are experimental, meaning that there is a difficulty in creating an experiment to test a proposed theory or investigate a phenomenon in greater detail. Here are some examples of unsolved problems in physics. Theory of everything. Is there a singular, all-encompassing, coherent theoretical framework of physics that fully explains and links together all physical aspects of the universe? Quantum gravity. Can quantum mechanics and general relativity be realized as a fully consistent theory, perhaps as a quantum field theory? Is spacetime fundamentally continuous or discrete? Would a consistent theory involve a force mediated by a hypothetical graviton, or be a product of a discrete structure of spacetime itself, as in loop quantum gravity? Are there deviations from the predictions of general relativity at very small or very large scales or in other extreme circumstances that flow from a quantum gravity mechanism? Dark energy. What is the nature and origin of the mysterious form of energy that is accelerating the expansion of the universe? Is it a cosmological constant, an inherent property of space itself, or something else? How does it relate to the vacuum energy predicted by quantum field theory? Dark matter. What is the identity and composition of the invisible matter that makes up about 27% of the mass energy of the universe? Is it made of weakly interacting massive particles, WIMPs, axions, primordial black holes, or something else? How does it interact with ordinary matter in itself? How did it form and distribute in the early universe? Black holes, black hole information paradox, and black hole radiation. Do black holes produce thermal radiation, as expected on theoretical grounds? Does this radiation contain information about their inner structure, as suggested by gauge gravity duality, or not, as implied by Hawking's original calculation? If not, and black holes can evaporate away, what happens to the information stored in them, since quantum mechanics does not provide for the destruction of information? Or does the radiation stop at some point, leaving black hole remnants? Is there another way to probe their internal structure somehow, if such a structure even exists? Baryon asymmetry. Why is there much more matter than antimatter in the observable universe? What mechanism caused this imbalance during the early stages of the Big Bang? Are there any domains in the universe where antimatter dominates over matter? Neutrino mass. What are the masses of neutrinos and how do they acquire them? Are neutrinos their own antiparticles, Majorana neutrinos, or not, Dirac neutrinos? How many types of neutrinos are there and how do they mix with each other? What is the origin and role of neutrinos in cosmic evolution? Quantum chromodynamics. What is the exact nature of the strong nuclear force that binds quarks into hadrons and nuclei? How does it give rise to phenomena such as confinement, the inability to isolate single quarks? Asymptotic freedom. The weakening of the force at short distances, chiral symmetry breaking, the generation of mass for light quarks, and color superconductivity, the formation of Cooper pairs of quarks at high density. How does it relate to other fundamental forces through grand unification theories? Quantum foundations. What is the best interpretation of quantum mechanics that resolves the measurement problem, the entanglement paradox, and other conceptual puzzles? Is there a hidden variable theory that is compatible with all experimental tests? Is there a way to formulate quantum mechanics without invoking the wave function or the collapse postulate? Does quantum mechanics allow for the existence of multiple parallel realities or many worlds? Extra dimensions. Does our universe have more than 3 spatial dimensions and 1 temporal dimension? If so, what is their size, shape, and number? How are they related to string theory and M-theory? How do they affect gravity and other fundamental forces? Are there any observable signatures or experimental tests for extra dimensions?